In this video, we're going to talk about circle theorem. And when we say circle theorem, that means we want to talk about how circle can relate with other triangles or other lines. In this problem, I'm not going to talk more on properties of circle. But before I start, what's the meaning of circle? We know that circle are set of points or collection of points in which all points are equidistant from a fixed point called the center. And that equidistance, we call it what? The radius of the circle. Now, from here, let's quickly talk about the properties of circle. Then we have radius. Radius is the straight line from the center of the circle to the circumference of the circle. The second one is 2 of the radius, and which is what? Diameter. Diameter is a straight line that touches the circumferences of the circle. That touches 2 points of the circumference of the circle and pass through the center of the circle. The next one is chord. A chord is a straight line that touches the 2 points on the circumferences without touching the center of the circle. So we call this one chord. We call this one diameter. Now, this chord, it always forms something. It causes something in this place. What does it cause? It causes us to have 2 parts of our circle. We have major segments, and that means from here to here is major segments, and from here to here is minor segments. Minor segments. So actually, from this also, it causes another thing again. What did it cause again? It caused this place. We call this place the minor arc, and we call this place the major arc. So from here again, what does it cause again? I don't think it causes anything. The next one that we have again is secant. Secant is the straight line that passes through the circle without touching the center of the circle. It does not touch the 2 circumference. It comes from outside and it went out. Then the last part that we have here again is we have tangent. A tangent is a straight line that touches the circumference of the circle at a point, and is always perpendicular to the radius of the circle. So we call this one a what? A tangent. Now let's now move to the theorems, the theories under circle. I'd like to take this away. So the first theory that we have under circle theorem is equal chords subtends equal distance from the center of the circle. What they mean here is that if I have a circle must have a center, yes. So they say equal chords, this is a chord. Let's say this chord is 10 centimeter long. If you have another chord here that is 10 centimeter long, what they are saying is that they will subtend equal distance from here. That means the distance from here to here is equal to the distance from here to here. If here is x, then here is y. That means x equals to y. That's the first theorem. Equal chords subtends equal distance from the center of the circle. That's theorem 1. Now moving to theorem 2, still using this circle. Theorem 2 simply says that angle at the center of the circle is twice angle at the circumference of the circle. Which means what they are trying to say is that this is the center of the circle. Now it subtends an angle. Then forming an angle at this center here, what they are trying to say is that angle at this center is twice angle subtended at the circumferences. Which means if here is theta, here becomes 2 theta. Which means I have that means if here is 30 degree, here becomes 2 times 30, that's 60 degree. As well as so there's some questions that they will give you this side, then you will not be asked to find this guy here. Remember, this is the reflex angle, which means angle at a point is 360. Which means if here is let's assume that we are giving here to be 30, then I ask you to find this place. That means here will be 300. If here is 30, here becomes 60. And that's 360 minus 60, that's 30. Don't worry, in the next video, we are going to solve questions regarding that. So the next one that we have, which is theorem 3, we said we are going to have angle on the same segment are equal, which means remember that time I said if you have a chord, this chord will cause something, which is what? Major segments and minor segments. Now, what they are trying to say is that if I have angle here, and I have another angle here, that means the angle in this point is equal to the angle in this point. If here is theta, here is theta. If here is 20, here is 20. If here is 10, here is 10. Angle of the same segments are equal. Both this angle, they are in what? They are in the major segment, so they are equal. So another thing that we have again is the theorem 4. That one is talking about semicircle. What does theorem 4 says? Theorem 4 says angle in a semicircle is a right angle, which means in this place, now the angle from here to here, that means Where is our perpendicular? This here should be our perpendicular, which means this angle and this angle will be sum up to 90 degrees. Okay, let's move to cyclic quadrilateral. What does cyclic quadrilateral says? Cyclic quadrilateral is saying that angle, sum of angle in a cyclic quadrilateral is sum up to 360, which means if I add this, let's say here is x, y, z, and this w. That means x plus y plus z plus w equals to 360 degrees. That is cyclic quadrilateral angle. Another one that we know about cyclic quadrilateral is opposite angle in a cyclic quadrilateral is sum up to 180 degrees, which means x plus w equals to 180 degrees and z plus y equals to 180 degrees. I think that's all, apart from the only about two that we have left. Yes, I think this is number 5. So number six that we have is we have a tangential law. Let's have our tangent. Tangent is very easy actually. What tangent is just saying is that a tangent is perpendicular to a radius, which means here is 90 degrees and here is what is as well 90 degrees. Another that we have is a chord sustains equal angle at the interior circle side and the exterior circle, which means from here, if I have something like this, okay, let's use to form a triangle. If this form a triangle, now what they are trying to say is that the angle in this place, if here is x, then definitely here too is x, which means we said exterior angle of a tangent is equal to what? The interior angle. Now, now I think this is the end of the video. In my next video, I'm going to drop the problem that we have solved on it. Please don't forget to like, comment, and share. Any problem that you have, drop it as a comment. Thank you.